Hello all. You know that eigenvalue problems and solving eigenvalues and eigenvectors are very important in many areas of physics. So today we are going to learn one of the iterative method used to find dominant eigenvalue of a matrix. So dominant eigenvalue here means that the largest of the eigenvalue associated with the matrix and the eigenvector corresponding to that eigenvalue. Okay. So this method which we are going to discuss in this particular session is called as power method. It is an iterative method implemented first starting with an initial starting vector x. So if I have a matrix say A, first I will assume an eigenvector x associated with that vector. Then we will adopt a method and finally at subsequent steps we find a more better approximation for this x, and finally we come to the original value of the eigenvector and the eigenvalue corresponding to that. Okay, so let assume that I have the vector A and let x be the initially approximated eigenvector corresponding to this matrix A. Okay, so let me write y matrix as equal to A times x, where A is a matrix and x is a column vector or the eigenvector corresponding to this matrix. Okay, so this is the initially assumed value. You can assume anything like 0, 0, 1 or 1, 0, 1, 0 or 0, 1, 0, something like that you can assume. Okay, then you know that if this is an eigenvector, I can write this as equal to say some constant which we normally call as lambda into x, right? If x is an eigenvector corresponding to A, I can write Ax is equal to lambda x, where lambda is the eigenvalue, which means that actually y is equal to lambda x. So I can find this x, I can find x from this equation as 1 by lambda into y. Okay, so so this is one way I can find x. What we do in the power method is that first if I'll be given a matrix A, I'll assume a matrix x as an eigenvector matrix, then I'll find out y equal to A times x. Okay, from the vector y there will be several values in the matrix or in the column vector. I'll pick the most significant value of say among the y as I'll take it out, and then I will find out 1 by lambda into y. Okay, so this lambda which I pick out from the matrix y, this is normally called as the scaling factor, and this is the element which is supposed to be largest in magnitude. Okay, and let me call here this lambda. Instead of 1 by lambda, which we normally call in eigenvalue problems, let me call it as using lambda as k. So you forget about the eigenvalue here. So I am calling it as a scaling factor. So that means if y is equal to ax, okay, in the next step I find out x as equal to 1 by k into y. Okay, but you can associate how this x becomes 1 by k into y. This k is the largest magnitude. It is the value which is the largest in magnitude in the elements of y. Y is a column vector which contains several elements. So k is actually the largest of the values in the matrix y. Okay, so thus we found y equal to ax. From that I found x is equal to k is the, I will find x as equal to 1 by k into y. Y is this one. Okay, then what is k? K is actually the largest value of the elements among the elements in the matrix y. Okay, so this I will go on doing in the repeated step. So first time I assumed, say I assumed x0, then I found y. Then I find the next value of x1 as equal to 1 by k times this y. Okay, so I got the next value of x1. Then I again find, in the next step I again find y is equal to again a times new x1. A is the vector as the matrix given. Okay, then I find, from this I find x2 as is equal to 1 by k times, it may be some another value. This is 1 by k1, let me call this k1 as, because this k1 is now the value which is largest in magnitude in the matrix y. Okay, so 1 by k1 into y, I got this y. Okay, then I got the new x2. With that new x2, I will find the new y as a x2. So this process will continue. Finally, I am coming to the point where this nearby x values, or the x1 and x2 values here. We found x1, then at the second step we found x2. Next step we will be finding out x3, right? 1 by k2 into y. I will find out x3. So when you continue this process several times, at some occasion you will find out that x2 values and x3 values are very close to each other, and finally you will stop working out with the x value. When that final value, which is in closer approximation with the previous value, when x2 and x3 becomes very close enough, that is according to my accuracy which is required, then I will stop doing the iterative. I will stop the iteration and finally say that this last x value is the actually the eigenvector corresponding to the most dominant eigenvalue, and the k corresponding to that is the dominant eigenvalue. Okay, so I hope you understood this, but while you do the problem it will become more clear. Here we are given a problem that it is to find the largest eigenvalue and the corresponding eigenvector of the matrix given. So the matrix is given here. So this is what we call as the A. So A is given here. Now the thing is, we have to assume the eigenvector, the vector which is asked here. That eigenvector has to be assumed. So for the time being, in this case, I assume the vector as 0, 1, 0. Okay, so I assume this x as 0, 1, 0. Okay, then you remember what is the first step? We have to find y equal to a into x. You find a times x. You multiply this matrix with this matrix. Okay, so when you matrix this, multiply this, I'll get 1 times 0, 0 plus 2. Plus 0. So that is, I'll get 2 here. Then I multiply again next row with this one. That is 2, 0, 1, 0. That is, I'll get 1 here. Then 0 into 0, 0 into 1, 0, then 0. So that the thing is 0. So this is actually a into x. You can multiply and find out what is a times x. So this is the first y value. Then what did I say? When to find x, what you will do? X is actually, I will write x as 1 by k times y. Y is this one. And what is this k? K is the largest of the values in the matrix y. So in the matrix y, which is the largest of the values, that is 2. So what I will do is, I will write 1 by 2 times, then I will write 2, 1, 0. Okay. Then what is 1 by 2 times 2, 1, 0? That is, when you multiply, divide each individual by 2, I'll get 1, then here I'll get 0.5, then I'll get 0 here. Okay, so this is the first step. So I'll find from the approximate x0, first initially approximated x0, I found out x1. Okay. Next my step is to find the x2. So that is the x2. So next is step of iteration. Okay, in the next step of iteration, again I have found out the new x. The new x is 1, 0.50. Okay, that is, you found what you found in the last step, 1, 0.50. Then with that x1 you find the new y. So I will find y is equal to 1, 2, 0, 2, 1, 0, 0, 0, minus 1, this matrix multiplied by the new eigen matrix, that is 1 0.50. You multiply these two each with, you try to multiply, you will get the value as 2.5 and then 0. You matrix multiplication you do and you will find out the value as this one. So in the next step I found out y equal to this value. Then what you will do, which is the most largest value in that, 2.5. So next k is actually 2.5. So again I am finding the new x is what? New x is 1 by k. K here is 2.5, the largest one among this. This 1 by 2.5 into, and I will do 2.5 and then 0. Okay. So then I will get the value as equal to 2 divided by 2.5, I will get 0.8, then 2.5 by 2.4, that is 1, again 0 divided by, that is 0. So I will get the next value as 0.810. This you have to continue for a long. So as long as you get the nearest x values very similar. So you go on continuing this. You have to do this. At the next step it becomes 0.930, and the next step you will get 0.9810. You continue going on. Finally it will converge at the point, say 110. You have to find. Finally when you come to around the 7th step, you will get the x value as equal to 110. In the 6th step as well as in the 7th step, the 110 will, you will get the same 110. And from that you will get the correspondingly the eigen value you will get as equal to, the most significant value will get as equal to 3. This you will try and find out. When you do this iteration several times, almost till around 7th time, 6th to 7th time, you will find out finally the eigenvector as 110 and the highest eigenvalue corresponding to that as 3. This you can work out and find out. Okay, so I hope you understood what power method is. Please understand the theory and then try to do this problem. Thank you very much.